Welcome to Hartman Math. This is lesson 8.1 Arithmetic Sequences. And that is pronounced correctly. As an adjective, we would say arithmetic. So take a look at the sequence that we're looking at and see if you can figure out the pattern. So what we're looking at is add 3, add 3, add 3, add 3. So anytime we're adding the same number repeatedly to create our sequence, that's going to be described as an arithmetic sequence. Each of these numbers in the sequence, we would say a term. We would say that's a term, that's a term. 22 is a term in the sequence. We would identify the terms usually with the letter A and then a subscript, saying this is A sub 1. The first term is 10. The second term is 13. So that's just a way that we identify specific terms. So what's A sub 3? 16. Now the question is, what would be the 100th term in the sequence? Clearly we don't see it, and clearly we don't want to take the time to write it all out. In fact, even if you did, it would be very easy to make a mistake. We want to be able to show some algebraic work to take a shortcut to get us there. Now, in an arithmetic sequence like this, the common difference, we use the letter D. The common difference is what was added each time. And we added 3. So 3 would be the common difference. And the way that we could calculate it, if we don't necessarily see it in there, is to take any term and subtract the one before it. 19 minus 16 is 3. Or 13 minus 10. You got to go that way with the subtraction. It doesn't work the other way. So we could do the second term minus the first, third term minus the second, the 41st term minus the 40th, and in this case we would get 3. All right, so let's see if we can kind of figure out a pattern based on this. We know that our first term is going to be A sub 1. In general, how do we get the next term? We would add the common difference. So we would take the first term and add the common difference. Now in this case it's 3. We're just talking in general terms. And then the next term, the third term, would be the one before it, like that one, add the common difference. But what is A sub 2? We just found out that A sub 2 is A sub 1 plus D. So we could replace A sub 2 with A sub 1 plus D. And then these are like terms. We could add those together. So the third term is the first term plus 2 times D. Let's do another one. The fourth term. By definition, the fourth term is the third term plus the common difference. And we just found out what the third term was. So we can replace A sub 3 with this. And these are like terms. So hopefully we're starting to see a pattern. Let's try another one. The fifth term is the fourth term plus the common difference. We go all the way through that and we can kind of see what's happening on the pattern. So in general, we're looking for the nth term, A sub n. This is essentially going to be our formula for this. So the pattern is A sub 2, A sub 3, A sub 4, A sub 5. In general, A sub n is A sub 1 plus some number times D. How does this number relate to our position, our subscript? How does this number relate to our subscript? How does this number relate to our subscript? It's 1 less. So when we write our formula, it's going to be A sub 1 plus 1 less than the n times d. And that's our formula for arithmetic sequences. A sub n equals a sub 1 plus n minus 1 times d, the common difference. So back to example 1, looking at that, remember when we were talking about how would we find a sub 100? Well, let's use the formula. A sub 100, so we're going to replace n with 100. We know a sub 1 is right there. We've already talked about our d being positive 3 that we're adding each time. And if we're talking about that n being 100, then that n is also 100. We can simplify that. Now take out the calculator. 10 plus 99 times 3, and we get 307, which would be the 100th term in that sequence. If you want to get full credit, you've got to show the algebraic work. All right, you try this one. Here's our sequence. Find the 57th term. Pause the video here, resume when you're ready. All right, so we would be doing a sub 57 equals first term, 41, plus n minus 1. So if we're talking about the 57th term, 57 minus 1 times. Now, careful on this one, because our d is negative, you're going to want to use parentheses, because otherwise, we might think, someone might see it and think it's subtracting 11. Your calculator might think it's doing that, subtracting 11. We want to show that it's multiplied by d, times d. So parentheses there. Wasn't necessary when the d was positive. So if we simplify this, we're talking about 56, negative 11. And then if you calculate it all out, you should get negative 575. Example number 2, find a sub n. So maybe not just a specific one term, but the general term, a sub n. We just use the formula. All right, a sub 1 is right there. Now the d, remember to get the d, take any term and subtract the one before it. Careful with the negatives here. Negative 19 minus negative 17. It's going to be negative 2. So we're replacing this, we're replacing this. We're not going to replace the n. We don't know what n is. Keep it as n. What we do want to do is simplify, though. Always simplify. So we're going to distribute here. And now we're going to combine like terms. And it doesn't technically matter the order that you have these in. It could be negative 11 minus 2n. I typically like to write it like this because it kind of connects back to linear functions, y equals mx plus b, that kind of a situation. All right, you try this one, find a sub n. Pause the video here until you got your answer. A sub n is the first term, plus n minus 1 times. The common difference is 5. Let's distribute the 5. Combine like terms. And you got 5n plus 40. We can give it a little try, see if it works. Like, what if I plugged in a 3? 5 times 3 plus 40 would be 55. And it matches what we have. Example number 3. We know the 10th term is 61, and we know the common difference. Find a sub n. So always starts with the formula. We're going to substitute for what we know. We're going to solve for what we don't. It's just a big algebra problem. So what we know is a sub 10, and that's going to go here. A sub 10 equals. First term, we don't know that. For a sub 10, if we're making it a sub 10, then we know n. If that's a 10, then that's a 10. And we know D, we were told D is 4. So A sub 10 is A sub 1 unknown plus 10 match minus 1 times 4. And that all equals 61 because that's what was told to us in the problem. So here's our equation right here. Talking about 9 times 4. Subtract 36 from both sides. We got A sub 1, our first term, is 25. Now let's go back to the original problem. That goes there. D goes here. We're going back to just finding A sub n. So all we got to do is distribute and combine like terms. A sub n equals 4n plus 21. Let's give it a check. Plug in a 10. 4 times 10 plus 21 is 61. Should be good. Example 4. Well, what if we don't know, for our formula, if we don't know A sub 1, we also don't know D. We know the 4th term, we know the 11th term. So we're going to use what we learned back in Unit 7, systems, for this. It's going to start with our starting equation for arithmetic sequences. And each of these terms is going to generate an equation. It technically doesn't matter which one we go with, but I like to use first the one with the larger n value further down in the sequence. So I'm going to start with this one. So n we're going to replace with 11. And that means that's going to be 11, and the whole thing's going to equal 20. So A sub 11 is the first term, unknown, plus 11 minus 1 is 10, times the unknown D, now will equal 20. Now right underneath that, pause here, write a similar equation for A sub 4. It should look like this. A sub 4 equals A sub 1 plus 3D is equal to 55. Now this is a special type of system where we have two unknowns. We have A sub 1 and D that are both unknowns. What we can do, which is a little bit different than when we did the addition method, is because these are guaranteed to match, we can just subtract our two equations to eliminate the A sub 1s. Subtract, cancel. Subtract 7D equals negative 35. Solve for D. Divide by 7. Now go back into one of these equations. I think I might choose this one. Substitute negative 5 for the D. We're going to solve for A sub 1. So positive 3 times negative 5 is negative 15. Let's add 15 on both sides. We got 70. We now know D. We now know A sub 1. Back into the original. Distribute. Combine like terms. A sub n equals negative 5n plus 75. If you want to check, plug in a 4. Do you get 55? Plug in an 11. Do you get 20? And that's going to check for you. That's it for today. I'll see you next time.